Hi guys, Mrs. Delisin here. Welcome to another lesson of Algebra 2. Today we're going to be learning how to determine the symbolic representation of a graph. We already did this one in quadratics, but this time we are doing it with polynomial functions. The step-by-step solution is the same, determining the symbolic representation of a polynomial given its graph. There are some twists to it though. Okay, so let's start. You can, of course, take a picture of these instructions here and then make notes, highlight stuff that you feel like it's important for you to remember. Okay, let us start. We have here determine the symbolic representation of a polynomial function given by the graph. We have a graph here, and the first thing that you always do is to identify your x-intercept. So I have, that is my x-intercept. Hey, look at that. You now have three x-intercepts. In quadratic, of course, we only have two, right? So we're moving towards to three x-intercepts. Sometimes we even have four x-intercepts in here. And let's start. I will be listing my x-intercepts. So I have, what is that one? Negative 2 comma 0, negative 1 comma 0, and is that a positive 1? Positive 1 comma 0. And if you remember, once we get our x-intercepts, we always then, right after, we make our partial solution, right? And so our partial solution would be f of x equals a. I always have an A, right? And then I am putting this into factored form. And because I have three x-intercepts, I'm going to have three of these. And I am putting, let's start with plus 1, right? And so when 1 comma 0 comes in as a factored form, if you remember, that becomes an x minus 1 because if we have what makes this whole entire thing zero, right? Because you know how your y is zero. If what makes the whole entire thing zero, it will be zero if we put a positive one in there, correct? And so if you notice, it will always be, technically I can call that the reverse of it. So if you have a 1 comma 0 in factored form, that was a x minus 1. Another is, if you forget, because if it's in a factored form x minus 1, and we want to get the x coordinate of the x-intercept, we make it equal to 0, right? So that's x is equal to positive 1. And that is the main reason why we have this as x minus 1. And then we'll put that in there. That is x plus 1. And then we'll put that in there. That is x plus 2. Okay, does that make sense? And then from there, our goal now is to find the value of a. And what we do is we will get another point in the graph, not the x-intercepts, okay? Another point in the graph that we could use to plug in so we can find the value of a. And usually our top choice is the y-intercept. So let's find out our y-intercept. It's right here. So our y-intercept, let's put that into, our y-intercept is, what is that? 0, comma 4. So I'm going to be plugging in 0, comma 4 as into my partial solution. Let us have our partial solution here. We have f of x equals a, x plus 2, x plus 1, and x minus 1. So I'm going to plug in 0, comma 4. So 0 will be plugged in as the value of x. And then 4 will be plugged in as, let's change the color so you can see. And then 4 will be plugged in as in replacement for f of x. And of course, I will just solve it from there. How 4 equals a, 2, 1, negative 1. That is negative 2, right? And so I'll divide negative 2 on both sides. And I will end up with a is equal to negative 2. And so I will now be deleting this a value here, and I'm going to change that into a -2. So my symbolic representation for the graph that is given in number 1 is -2 times x plus 2, x plus 1, and x minus 1. Not that bad, right? Okay, let's move on to the next one. Determine the symbolic representation of a polynomial function given by the graph. Let us find first, as always, our x-intercepts. So my x-intercepts where are they? This one and that one. So what is that? Is that a -1, 0? And then I'll also have 2, 0, right? -1, 0, and then 2, 0. And then I will make my partial solution A. This one, because I have 2, I'm going to make a space. I have 2. This one goes in there. That is x minus 2. This one goes in there. That is x plus 1. Okay, but I would like you, this one has a twist to it. Before I find the value of A, I think something is different in this graph. So let us compare. Let me compare these two graphs right here. Okay, you notice this one. It's coming down here when it hits, right? When it hits the point, it went up. Okay, when it hits the next x-intercept, it went down. When it hits the next x-intercept, it went up. So technically what I'm trying to say is it just passes through. It hits, pass through, hit, pass through, hit, pass through. Correct? Right. And then this one, it's coming from up here. It hits and it passes through. It hits the y, it passed through. It hits but it didn't pass through. There is something wrong in here, or not wrong, but there's something different in it because this one is supposed to hit and pass through like all other points that we've seen before. But this time it did not pass through, it bounced back. What I'm saying is that when it hits, it's coming from down, it bounced back down, right? It bounces. And so why don't we name this thing? Let's name this pass through or PT. This is pass through, pass through, pass through, right? It hits the point and it goes through the point. It hits the point, it goes through the point. But this one, it hits the point, it didn't go through the point, it bounces back to the point. So let's call that B as in bounce back. And the reason why it bounced back, it's because this one is twice. This X is used twice. Oh my goodness, miss, what are you talking about? I'm talking about that here when I say, let me go back to number 1 quickly, okay? So for the X plus 2, the x-intercept, where is x plus 2? This one right here. It passed through, that means that's only used once. Then this one is only used once. Then this one is only used once. For the x minus 2, which is this 2, 0, because it passes through, that point is only used once. But because for the -1, 0, it did pass through, it bounces. That means that that point is not used once. This one was used twice. And the reason for that is, and that means we have 2x plus 1. So I am going to delete that. Take a look. That means that you have 2 of the -1, 0. Does that make sense? Okay. And my x plus 1 is being squared right here. You do not have to write x plus 1, x plus 1, and x minus 2. You can just put squared. That is to indicate that there was a bounce behavior that happened at that point. Okay? Let's remember now. When it just passes through, the point is used once only. If it bounces back, the point is used twice. That makes sense? All right, moving on. Let's have our y-intercept. What is y-intercept? Purple. Y-intercept is that one right here? 0, comma, what is that? -5. 0, comma, -5. Now, we can solve for our a value. So we have f of x equals a, x plus 1 squared, because there's a bouncing behavior. It's used twice. And x minus 2, you don't have to put to the power of 1. And then we are going to plug in our 0, comma, -5. So let's plug that in. We have -5 into the as a replacement for f of x, and then we'll continue on 0 plus 1 squared, 0 minus 2. That's -5. 0 plus 1 is 1. 1 squared is 1 again. -2, that's -2. 1 times -2 is -2. So our a is equal to, wait, let's put that again in here so we don't get confused. So we will divide -2 on both sides, right? So our a is equal to 5/2. Okay? And so over here, I will now be deleting that a, and I'm going to change that to 5/2. Okay, you guys? Got it? So we learned something new today. The bouncing behavior of a polynomial function, meaning that that point was used twice. What happens if the point is used 3 times? Do you think that's possible? Okay, let's see. We don't know yet. Number 3, determine the symbolic representation of the polynomial function f of x given by the graph. Okay. What do we need to figure out? Let's figure out our x-intercepts. And we usually call it at red. That is an x-intercept. That's an x-intercept. So x-intercept, we have, what is that? Is that a -1? -1 comma 0. And then 1 comma 0. +1 comma 0. Okay? And then let's put a, and then parenthesis, parenthesis. When that goes in, what is that? X minus 1. When that goes in, that is x plus 1. That makes sense, you guys? All good? We're good? Okay. And then let us try to investigate if there is something new to this graph. Okay, let's compare, compare, compare. This point right here, is that a passing through? Is that a PT? Because it hits and it goes through. So we call that PT, right? We call that PT earlier, right? So we call that PT, meaning passes through. And if it passes through only, and then that means that is only used how many times? Once. Okay? So the x plus 1 or the -1 comma 0 was only used once. So there's only one x plus 1. I hope that is making sense. And then for the x minus 3, do you that seems different too, yeah? I know it passes through. Let's try to look. You know how I know it passes through, but it looks like there's some kind of a curve going on before it went down. Do you guys notice that? Let's make that bigger. Do you see? And let me clean it up a little bit so we can see the difference. Do you see the difference between this passing through and that passing through? This one seems to be different because there's a curve that is happening, correct? Okay, so that is a curve behavior. Let me go back there. Let me put the red back again. There is a curve behavior. That means this point is used 3 times. Okay, not once, not twice, but 3 times. And so there should be 3 of the 1 comma 0 because the curve in the point means that the point has been used 3 times. And so because this one, and so because that's too much, right? And because this one was used 3 times, I will put that wonderful 3 on top in there, indicating that the point was used thrice, indicating that there is a curve behavior in the graph. So we have PT passing through, we have bouncing using that's used twice, and now we have a curve, which is the last one. We're not gonna have 4 or 5, whatever. We're just gonna be learning on 1, 2, and 3. Okay, that makes sense? And let's move on to our y-intercept. Okay, I'm hoping that this is not too much for you guys. We have our y-intercept right here. What's that? 1, 2, 3, 0, comma 3. Okay, so we have f of x equals a x plus 1 only use once. You don't have to put that, but that's just, to indicate that we know it's used 3 times and the other one is only used once. And then I'm going to plug in, what do I plug in? Plug in 0, comma 3. And we have 3 in replacement for f of x. And in replacement for 0, we put 1. Put in replacement for x, we put 0. 0 minus 1, cube, don't forget. We have a, that's a 1. Negative 0 minus 1 is a negative 1. Negative 1 cube or negative 1 times 3 times, that is just a negative 1. So we have 3 equals negative 1. So divide by negative 1. A is equal to negative 3. And so instead of this A value here, I will put negative 3. Okay, that's it, you guys. Let's take a look at the homework page. For number 1, not a big deal. They're all passing through, pass through, pass through, pass through. No problem. There's just 1, 1, and 1. Okay, for number 2, we have a pass through 1 time, pass through 1 time. Oh, we have a bounce 2 times. Okay, pass through 1 time. Ooh, 3 times. And then this is 1. Okay, here's the scenario for number 3. I'm gonna start it and you guys gonna have to finish it, okay? I have x-intercept. I will do, what's that one? 1, 2, and 3. Negative 3, comma 0. Followed by, we have an x-intercept at the origin. 0, comma 0. Oh, because it's done twice, should I really write 0, comma 0 and 0, comma 0? Why not? Okay, but you don't have to write all 3 of them. The only reason I'm writing all 3 of them in this example is that you will remember that it's repeated 3 times. Okay, and then what's the other one? Is that a positive 2, comma 0? Okay, and then I'll have a, and let's put that in. This one goes in as x plus 3. This one goes in as, oh, let me put that in first. That is x minus 2, right? I don't need the arrow there. It's going to get confusing. This one goes in as x minus 2. And both of them, the x plus t and x minus 2, both of them are just ones. And this is our problem here. this one. How are we gonna write that? Like, do we write that on x plus 0? Why not? Let's change the color because it's something peculiar. X plus 0 to the power of 3. Now, you know how it's just x plus 0 to the power of 3? Can I just write that as x cubed instead? You can. You know what I mean? Like, you can just do it this way. Just that. X cubed. And that is perfectly fine, you guys. But for sanity purposes, let's put x plus 0 in there. But again, you don't have to. Okay, here is our big problem. Our y-intercept in here is 0, comma 0. So your y-intercept and your x-intercept are the same. And because they are the same, you are not allowed to use the y-intercept to plug in into your equation because you've already used 0, comma 0 as your x-intercept. So I'm going to give you a clue. You will find a different point in the graph that you could use to find your a value. And that point would be this one right here. That is a negative 1, comma 4. So another point, which is negative 1, comma 1. Is that correct? Negative 1, comma 1. Okay. I hope this lesson is helpful. This video, I mean, is helpful. If you have any questions, let me know. I will see you guys in the next video. Thank you guys for watching. Bye.